Hi friends, Mrs. Derby here, and you guys are there. And we're starting lesson 6 here in Algebra 2. So I always start with my classes here on the cover page. It's always good to see what we're going to be talking about in this unit. Plus, we often put a lot of our important notes here on the outside. So in Unit 6, what we are talking about is the unit circle, and we'll see what the other part of that's going to be. Let's define what the unit circle is. Of course, it is a circle, so that's good that you guys have had geometry before. And it is set usually right here in the middle of a coordinate grid around the origin. And we call it the unit circle because, in fact, its radius is 1 unit. And so, given points on the outside, we could start to add some coordinates already to this thing called the unit circle. If the radius is always 1, each of our coordinates is going to be 1 unit away from the origin, and we just need to think about which direction they are for positives and negatives, like that. We're going to work with that unit circle throughout this chapter, and we're not going to be stuck with just the points at the 4 quadrants there. We'll be able to use all kinds of different points, and I bet if you're seeing me do something like this, you might already have an idea why we're going to be looking at clocks on the first page. Aside from the unit circle, we are also going to be talking about these things called periodic functions. Periodic just means it's something that repeats at a regular time. That's all that this means. So it repeats regularly. So a periodical in the library is like a magazine or a newspaper that comes out at the same time. So maybe it's once a month, maybe it's every day that they have a new newspaper. It's a periodical. When you have something like first period, second period, and third period, you would be going at the same time to each one of those, and it would be the same routine each day. It repeats regularly. So we're going to be looking at periodic functions. Now these are going to have something to do with the unit circle. And because they repeat regularly, we're actually going to be using some of the things that we saw last unit as we were rotating, reflecting. And so we'll see that it starts and stops at a certain point, and then it repeats itself. So there are lots of periodic functions. Now, it should not come as a shock to you that once we have those periodic functions, the end part of the chapter, this Unit 6, is going to also incorporate what we learned in Unit 5. So we can start taking those periodic functions, and we can start doing things like shifting them downward. Or perhaps we can also do some other things like stretching them taller. Or maybe we'll get even a little bit wild and we'll move things to a new location by moving it up and over. So we'll be looking at some of those. So there's our title page, great things to think about as we tackle Unit 6. Part 1 of Lesson 1 starts with a which one doesn't belong. Remember, there is no right or wrong answer for each of these. But the idea is to come up with a reason for each one of them, why they don't belong with the others. So I might say B doesn't belong, because all the rest of them have at least one hand that points to 12. Maybe I'm going to say that C doesn't belong because it's the only one that points to something on the left half of the clock. Maybe you're going to start bringing in some other ideas from geometry, and maybe you're thinking that this is the only one with a right angle. And if that's the case, then maybe you're seeing that these two are greater than 90 degrees. This one is less than. We call that acute because it's so cute. Anyway, keep on thinking about why those wouldn't belong. You can keep on going with that, but I'm going to move on to section 1.2. This is where we're going to start going around and around. A ladybug lands on the end of a clock's second hand when the hand is pointing straight up. If you have been in my classes before, you know that I am a very visual learner. And so I'm going to draw that clock with the second hand, and here is my little ladybug here at the top. The second hand is 1 foot long. Well, that's looking an awful lot like the unit circle we just drew. When it rotates, the second hand is 1 foot long, and when it rotates and points directly to the right, the ladybug is 10 feet off the ground. So now here's my ladybug. And at this point, wherever this clock is hanging on the wall, down here to the floor, from here, is 10 feet. How far above the ground is the ladybug after 0, 30, 45, and 60 seconds have passed? All right, okay. So right now the ladybug, we're going to go back to it starting at 0 seconds, that it's up here at the top. Okay, it just says down here that when the second hand is 1 foot long, and when it rotates and points directly to the right, the ladybug is 10 feet. So we're not going to start with that 10 feet here. We're starting with it right up here at the tip top. So after 0 seconds, if we want to think about how far above the ground would this ladybug be after 0 time has passed, well, if it's 10 feet from the ground to this point, right, that means even this part is also 10 feet because they're parallel and equal. So it's 10 feet from the ground to the middle of the clock, and then it's a 1 foot long second hand. So at 0 seconds, it would be 11 feet off the ground. At 15 seconds here, and notice that they don't ask us 15 seconds because we already figured that part out. At 15 seconds, it's 10 feet off the ground. At 30 seconds, I'm going to do this one in purple. 30 seconds means that the clock has come down here, and from here to the ground, let's see, we don't have that full 10 feet anymore that would have gone up here. Instead, we are 1 foot less than that. All right, we were at 10 at this height, now we are 1 foot less than that. So here we are at 9 feet. At 45 seconds, our ladybug would be right here. Same height as at 15 seconds, at 10 feet. And last but not least, at 60 seconds, it would be right back up to the top up here. 60 seconds at the top of our clock would again be the same as 0 seconds, so this would be back at 11. We can even put that it's the same as 0, because we're right back to where we started. So if we needed to estimate how far off the ground the ladybug is after 10, 20, and 40 seconds, be prepared to explain your reasoning. Well, let's see. If we're thinking about for 10 seconds, we know at the start up here it was 11 feet off the ground, and by the time it got here to 15 seconds, it would be 10 feet off the ground. So we know it has to be between 10 and 11. Feet off the ground. And because we're looking at 10 seconds, 10 seconds would be right about here. That is closer to 10 than it is to 11. Right, it's not right smack dab in the middle there. So we might be thinking that maybe it's like 10.3-ish feet or something. So it's kind of a nice estimate. And we can explain that reasoning just like we did. So put that into words about how we would go about that. 20 seconds. Well, here we are at 15, and so 20 would be right about here. Again, it's between the 10 feet off the ground and the 9 feet off the ground. And it's a little bit closer to the 10 feet off the ground kind of part. So I would actually say it's probably right about at 10.3-ish feet. That single tick mark, by the way, is the shorthand for feet that we have there. So it'd be about maybe 10 1/3 feet, right? And at 40 seconds, well, 40 seconds is over here. It's 5 seconds away from 45. What do you know? Wait a second. This should be... Sorry about that. That should be 9.6-ish or something like that. Oh, I caught myself. Because it makes sense up here, if we're talking about this being about 10.3 feet, this would have to be below 10. I was still thinking between 10 and 11, but we saw it was between 9 and 10. Look at that. Even teachers make mistakes. So at 40 seconds, it's actually going to be about the same height here as 20 seconds. So probably somewhere between 9 and 10 and closer to 10. So I might say 9.6-ish. Now this ladybug is on the second hand. If it stays on the second hand and keeps on swirling around this entire clock all the way around, describe how its distance from the ground will change over the next minute. What about the minute after that? Well, we just saw how it changed from 11 feet to 10 feet to 9 feet to 10 feet to 11 feet to 10 feet to 9 feet to 10 feet to 11 feet. 10 feet to 9 feet to 10 feet to 11 feet. It's going to keep on doing that same rotation. So when we think about its distance from the ground, how it will change over the next minute, every minute will change from 11 feet to 10 feet to 9 feet to 10 feet and end at 11 feet. And the minute after that will be the same. It will continue to rotate. So the distance will continue. And it will repeat the same pattern. We've been looking at patterns since Unit 1, where we were looking for like series and sequences, right? So we're still always looking for patterns going on here. At exactly 3:15, the ladybug flies from the second hand to the minute hand. At exactly, oh, that's a terrible clock. Don't draw that clock. Here's 3, here is 15, and here is the second hand. So this ladybug is going to fly from the second hand up here, and is going to land right here on the minute hand at 3:15. How far off the ground is the ladybug now? Well, we're still pointing at the 15 over here. We're still pointing exactly to the right. And if it's the same clock, it's going to be the same height where we started. So this would still be 10 feet off the ground. And at what time will the ladybug be at that height again if it stays on the minute hand? So this time our minute hand now needs to go around here. And at this point, it will be at the same height off the ground. So right here, and now we're talking about the minute hand, so it was 3:15 over here. The minute hand needs to swing over to this side. So that would be at 3:45. when the minute hand is pointing straight left. Nice place to begin with our warm-up and our section 1.2.